Alrighty, welcome. Today we're going to be having a look at exact values of trigonometric functions. Now, for today's lesson, we're just going to be focusing on 90-degree turns. Except in trigonometry, we tend to not use degrees. Instead, we use a unit called radians. Now, a radian is based off a half turn, meaning that 1 radian is related to this idea of a pi turns. So we would call this angle here, pi. And so everything we do is going to be based around pi. Now if you notice, pi radians is equivalent to 180 degrees. Therefore, pi on 2 radians is going to be equivalent to 90 degrees. So in today's lesson, we're going to be focusing on pi on 2 radian rotations. I'm going to be having a look at a bunch of different ones. So, for example, we could rotate pi on 2. We could rotate pi, so that would be a full pi. We could rotate pi on 3 pi on 2. Or we could, even if we wanted to do a full rotation, we could do a full 2 pi rotation. Now, one thing you'll notice when I'm doing these rotations is that I always start from here. Now, this point here, right, this is x and this is y, is on the unit circle. And this unit circle has a radius of 1 unit, meaning this point right here, that would be 1 on the x-axis, 0 high, so 1, 0. This point up here would be 0, 1. This point over here would be negative 1, 0. And this point down here would be 0, negative 1. So all of our rotations can go onto there. Now, a few points of notation. These pairing points are obviously x, y points. But in trigonometry, we don't call them x, y. We actually call them something else. We say that it is the x and y are represented by sine of the angle, cos of the angle, sine of the angle. Meaning, if you have an angle, let's say theta degrees, then this point here can be represented, the x-coordinate is representing cos of theta, and the y-coordinate is represented by sine of theta. Alrighty. So, let's have a play around with this idea. So, if I would to say ask for something like this, let's say the sine of 3 pi on 2. Now the first thing I'd get you to do is to draw in your unit circle. I've already done that here. The second thing is to draw in the angle. So 3 pi on 2, well this is 1 pi on 2. This would be 2 pi on 2s. So this angle here would be 3 pi on 2. And the second part of it is to do with whether it is sine or cosine. In this case, it's sine. Now remembering, the x-coordinate, y-coordinate match up with cos and sine. Therefore, since we're interested in sine, we're interested in the y-coordinate, which means we're interested in the negative 1. What's the y-coordinate after 3 pi on 2 rotation? Well, it's negative 1. Let's have a look at a different one. Let's try and say the cos of 3 pi. Well, 1 pi represents the rotation halfway across the circle. 2 pi would be back to where we started, back to the start. And a third pi would take us back out to here. And so the angle we would be looking at would be this one here. We've done a full rotation plus a pi rotation on top of that. And because we're interested in cos, well, cos is asking for the x-coordinate. Well, what would this point be? Well, this point here is negative 1 on the x-axis, 0 high. And so we would get that the x-coordinate would be negative 1. Alrighty, so that's a quick introduction to reminding ourselves. If I wanted to do a larger rotation, let's have a look at that. Let's have a look at 15 pi on 2. Now the first thing I always like to do is draw my unit circle and then visualize what's about to happen. Now, 15 pi on 2 is a lot, and if I wanted to count this exactly, that would be quite challenging. So instead, I'm just going to subtract off 2 pi. Why? Because if I'm, say, here, at this angle here, and I rotate a further 2 pi around, well, I'm going to end up all the way back to where I started. So it's as though I've done nothing. So therefore, you can add or subtract 2 pi to the angle to change it to something a little bit easier to work with. So I'm going to subtract 2 pi. But subtracting 2 pi is quite difficult because if you can't tell, this is in halves and this is in wholes. So instead, let's write this as 4 pi on 2. Now this is a much easier calculation to do. So 15 pi minus 14 pi, well that's just 11 pi on 2. But we're still quite a lot of pi's still, so I might repeat this again and subtract off another 4 pi on 2, which is just 2 pi. And that's going to get me down to the sign of 7 pi on 2. Can I do this again? Yes, I can. Subtract off another 4 pi on 2. And I'm left with the sign of 3 pi on 2. Hey, I just did this angle. I remember this one. So 3 pi on 2 is going to be half a pi, 2 halves of a pi, 3 halves of a pi. This angle right down here. So this is the angle I'm interested in, and this is the point. Now obviously I've done a few extra rotations, so the real angle is actually 1, 2, 3, 4, 5, 6, and then out to there. But it doesn't actually matter how many times we've gone around the circle. We only care that we eventually end up out there. Now, this point here is 0, -1. And since we're interested in sine, sine is interested in the y-coordinate, and so we get -1. Alrighty, so that's just a quick introduction to doing a little bit of work around this. Exact values of trig functions. We're going to be doing a lot more of this coming up, but we're going to go slow for the beginning. Alrighty, see you in the next one. Bye.